Hi everyone, welcome to Network Umpires. My name is Pawan, and today we will discuss one important topic in our enterprise network. So the topic is NAT. The topic is what? Network Address Translation. Okay, so before starting this NAT, first of all, we need to know why do we use NAT. Okay, so first we will discuss why do we use NAT. Okay, now so I'll give you one example. Okay, like why do we use a NAT? First of all, we'll discuss like basic, very basic, like what is actually the NAT, right? So NAT is what? I'll show you. Let's take an example. Let's say this is ISP, Internet Service Provider, right? And this ISP is connected with this one router. This is router 1. And after that, in our network, we are using one switch. So this is switch 1. And we have like a lot of PCs right now. Right. So this is like very basic network. And let's take an example. These PCs having IP address 192.168.10.1, and this PC having IP address 192.168.10.2, 10.3, 10.4, and then 10.5, right? And this router having two interfaces. Let's say one is F0 by 0 and another is F0 by 1, right? So this F0 by 0 interface having IP address, let's say it is okay, let's say it is 192.168.20.1. Okay, and this interface having IP address 192.168.10.100. It means this 10.100 is the default gateway of every PC. 10.100. Okay, every PC having this default gateway 10.100, right? Okay, and here we have ISP, and ISP is also connected with google.com. So it is the Google IP address is 8.8.8.8, right? Okay, so this is the very small network. Okay, so what happening right now? Okay, guys, right now in this company, let's say this is a small enterprise network, small company. So in this company, let's say it is any company. Okay, and in this time, this company having how many PCs? 1, 2, 3, 4, 5. Only 5 PCs, right? And guys, I have a one question for you. In IPv4, I'm talking about IP address, Internet Protocol. In IP addresses, how many? Okay, if I'll talk about the IP address, so there is a two version, right? One is what? IPv6, and one is what? IPv4. So right now I'm talking about IPv4, right? So in IPv4, what is the size of the IPv4 address? That is 32-bit. The size is what? 32-bit. So if I'll like take a calculation 2 raised to power 32, so maybe like it is approximate 4 billions, right? So in IPv4, how many IP addresses are available right now? In IPv4, we have 4 billions of IPs, right? And let's take an example. This company having how many employees? Let's say 1 lakh employees. How many employees? 1 lakh employees, right? So it means if we have 1 lakh employees, so obviously every employee having a one PC as well, right? One machine as well. So it means how many machine we need in the company? 1 lakh, right or wrong? Perfect. So we need 1 lakh machines, 1 lakh PCs in our company. And if we have 1 lakh PCs in our company, so obviously we need 1 lakh IP addresses as well. Yes or no? Because we need to assign IP addresses, each and every unique IP address like that. So right now in my company only 5 PCs. So every PC having a unique IP address. Exactly same thing. If we have 1 lakh PC, so obviously every PC having a unique IPv4 address. Alright? Perfect. So guys, this company using how many IP addresses? 1 lakh IP address. Exactly same. Let's say if we have any another company, in all over the world there is a lot of companies. This is also a company, here one more company is there, here one more company is there, here one more company. Like if we have lot of companies, so obviously in IPv4, if I'll talk about the IPv4, so in IPv4 we have billions, 4 billions of IP addresses, right? So those 4 billions IP reduces, right? And after some time, we do not have any IPv4 addresses. So this is what problem. Because if all over the world, obviously, the IPv4, how many IPv4 addresses we have? 4 billion IPv4 addresses, and the population, if I'll talk about all over the world, it is more than 4 billion, right? So right now IPv4 addresses are reduces. So how to stop this IPv4 reduces? Our IPv4 addresses are finishing, right? So how to save those IPv4 addresses? The first solution is what? Anyone know? The first solution is what? Subnetting. Okay. And the second solution is what? NAT, network address translation. So the question is what? Why do we use this topic NAT? Why do we use this NAT topic? The answer is this one. It can limit the waste of IP addresses by using the private addressing scheme. Now what is private what is private addressing scheme? Okay, if I talk about IP addresses, see, this is the important thing. If I talk about IP address, so first we have what? Private IP, and then we have private IP range, and then public IP range, right? So can you see here? Okay, guys, anyone know what is the range of class A? Okay, someone is saying it start from 1 to 126, or someone is saying it is start from 1 to 127, right? So it means it is start from 1 to 126 or 127. So right now, if I'll talk about the class A IP, so this 10.0.0.0, it is a class A IP, right or wrong? 10.0.0.0, perfect. So if this IP address is class A IP, So this range, it means, okay, wait. Let's take an example. Class A start from 1 to 126, right? Okay. So in this time we have 1, 2, 3, 4, 5, 6, 7 till 126. But when we start from 1, 1, 2, 3, 4, 5, 6, 7, 8, and then what? 9, and then what? 10. So just to skip this 10 and start from 11, 11, 12, 13, 14, 15, 16, 17, 18 till 126. So it means 12, 13, 14, 15, and then 125, and then 126. So where is this 10 range? This 10 one. 10.0.0.0. So actually, in a class A IP, this 10 range, this whole 10 range is reserved for private IP. Got it? And this range 1, 2, 3, 4, and then 11, 12 till 126. Those all IP address what? Public IP. Exactly same in class B and exactly same in class C. So in every class, we have a private IPs and public IPs, right? So right now I'm talking about private IP addresses. So this is the range of private IP address. This is the range of class A private IP address. This is the range of class B private IP address. This is the range of class C private IP address. I hope this thing is clear to everyone. It means in IP addresses, we have what? Private IP range, and we have what? Public IP range. This thing is clear? Okay. So I hope this thing is clear to everyone. It means we have private IP and we have public IP. Okay. Now the question is what? Where we are using private IP and where we are using public IP, right? If I talk about private IP, so private IP we are using in our LAN network, right? And where we are using a public IP we are using on WAN network. Got my point? Okay. So I hope this thing is clear to everyone. Public IP, we are using WAN network. Private IP, we are using LAN network. Okay. Guys, right now, my PC is also connected with Wi-Fi, with wireless network. I'll show you. So my PC is connected on which Pawan 5G. Can you see? Pawan 5G. So my PC is connected with this SSID. Okay. So the thing is what? My PC is also having an IP address. I'll show you the IP address of my PC. And just to tell me, guys, this IP address is private or public? Okay. Yeah. IP config. Say enter. And right now I'm connected with the wireless network. It means my wireless Wi-Fi. So it will be show me wireless LAN adapter. IP address is what? 192.168.1.63. And guys, can you see here this IP address belongs to which private or public? It is private IP range. You can check as well. 192.168.1.63. And here you can see it is start from 192.168. Right? 192.168.0.0. It means my PC IP is also, it's a private IP because I'm sitting at the right now where I'm sitting at where LAN or WAN? LAN, local area network. That's why it will be show me a private IP address. It means private IP we are using where? On LAN network, and public IP we are using what? WAN network. I hope this thing is clear to you. Now, so the question is what? why do we use NAT? So using the NAT, when we are using NAT, basically like actually what the NAT is doing actually, it's a way to map multiple private addresses. Why do we use? It is used to, we can say, translate. Why do we use NAT? It is used to translate private to public IP. Private to public IP, and we can say vice versa. Public to private as well sometime. Okay. So if someone asks a question, why do we use, or what is actually a NAT? So NAT is a translation. Okay. Or NAT is a way to translate the private IP into a public IP and vice versa. It means public to private as well, right? So the same thing he's explaining here. It's a way to map multiple private IP inside a local network. Because I told you where we are using a private IP. Private IP we are using in LAN. It means our local network. So it is a way to map multiple private addresses inside a local network to public IP address. Okay. So what is NAT? NAT is a strategy, or NAT is a way to translate private IP into a public IP and public IP into a private IP, correct? And in many organizations, see the second line, organizations that want a multiple devices, because if we have a multiple employee, 1 lakh employees, so obviously we have a multiple or 1 lakh PCs. So organization that want multiple devices to employ a single IP address using a NAT. Okay, it means okay. See, I'll explain you here. So let's take an example. Again, the same topology. We have one ISP here, and this ISP is connected with R1 router, and this R1 router connected with the switch, and this switch is connected with 1, 2, 3, 4 PCs, right? So let's say this is 10.1, 10.2, 10. Sorry, it's 3. And then what? 10.4. And guys, one more thing. If I'll talk about the private IP, so private IP is what? Free. And if I'll talk about the public IP, so you need to purchase this IP address. Yes. Got my point? If you want to use any public IP addresses, so you need to purchase, you need to buy this IP, this public IP. Okay. And this private IP address is free. Okay. Now, so actually, let's take an example. In this, this is a ISP 8.8.8.8, and this PC having IP address 10.1, 10.2, 10.3, 10.4, and in this port on this side we have 10.100 IP, and here we have 20.1, and here we have 20.2. Right. So this is the topology. This is the small topology. So where we are implementing a NAT? NAT we are implementing on edge device. Edge device, what is the meaning of edge device? The device is connected with your ISP as well as the device is connected with your LAN network. It means the side device, the edge device. Okay. So maybe it is firewall as well. Yes, if in your company, if we have a firewall, so always we will implement this NAT on the firewall. Okay. So let's take an example. In our network, we will implement this NAT On which device? On this router, the edge router that is connected with the ISP, directly connected with the ISP and directly connected with our LAN network. So whenever if this PC, this 10.1 PC wants to communicate 8.8.8, it means google.com. So first of all, this PCs forward the packet towards switch, and switch will forward this packet to router, and routers forward this packet to ISP, and ISP will forward this packet to google.com, like that. So this is the flow. Okay. So in this flow, what is the problem? Guys, this is the very, very important thing. Very important thing. I will show you. Before starting this important point, I'm telling you 2 or 3 important points. The point is what? See. Private IP is not routable, or public IP is routable. It means one thing here, and we don't have private IP route inside the ISP routing table. It means, okay, I will explain you these 3 lines. You understand right now private IP and public IP, right? So this is what ISP, Internet Service Provider. So in this ISP, we don't see which type of route? Private route. Inside the ISP routing table, they don't show me the private route in our routing table. Only in our local network, we are seeing the private IP here only. So it means here we are using what? Because this is a LAN. Here we are using private IP, and here we are using public IP. Right? So the thing is what? It means here we do not have, here on ISP, we don't have a private IP address. Never. Okay. So now let's take an example. This is R1 router. This router is what? R1 router. And this router having a routing table, because right now this router having how many ports? This router having 2 ports, F0 by 0, F0 by 1, right? Okay. So, and on F0 by 0, this is the IP address, and on F0 by 1, this is the IP address. So obviously every router having its own routing table. So let's say this is the R1 router routing table. So in this routing table, we have F0 by 0 port, and we have F0 by 1 port. So on F0 by 0, let's say 20.0 network inside the routing table, and here we have 10.0 route inside the routing table, right? Okay. And if I talk about the ISP routers also having a routing table. So right now ISP is connected with this link. So on ISP side, let's say this interface is, again, it's F0 by 0 on ISP. Okay. And IP address is what? 20.2. It means the network address is F0 by 0. The network address is 20.0. And ISP is also connected with 8.8.8. It means google.com. Let's say this interface is, it's example only, F0 by 1, F0 by 1. And here we have 8.8.8.8, right? So this is the topology. Let's say this PC 10.1 wants to communicate 8.8.8.8. So what is the flow? I'm talking about right now flow. If this 10.PC, 10.1 PC wants to communicate 8.8.8.8, so the source IP address is what? 10.1, and the destination IP address is what? 8.8.8.8, correct? So this PC forward this packet towards switch, and switch will forward this packet to router, right? And one more thing, inside the router, we will also using a default route from this router to ISP. It means In the R1 router routing table, it will be show me this route as well. 0.0.0.0 pointing towards 20.2, right? So now let's talk about again the same flow. It means when this 10.1 wants to communicate 888, so the source IP address is what? 10.1 and the destination IP address is what? 8.8.8.8. It means this PC forward this packet towards switch 1 and switch 1 forward this packet to this R1 router. Now, this R1 router receive this packet with source IP 10.1 and the destination IP is what? Tell me guys. Perfect. 8.8.8.8, right? Super. Now, everyone know whenever a router receive any packet, so directly they will check the destination IP. And right now the destination IP address is what? 8.8.8.8, right? So this router check the routing table. We have any 8.8.8.8 route? No, here we have 10.0 and here no, here we have 20.0. We do not have any 8.8.8.8 route, but yes, we have a default route. Default route, it means 0.0.0. And what is the meaning of default route? It means any IP allow. Any IP allow. And this default route pointing towards 20.2. It means pointing towards 20.2. Where is 20.2? This is the ISP IP. It means what this R1 router will do in this time, this R1 router forward this packet where? To ISP router, correct? Yes or no? This R1 router forward this packet to ISP router and ISP router forward this packet to this google.com 8.8.8.8. It means right now this ISP will receive a packet with source IP 10.1 and the destination IP is what? 8.8.8.8. Yes or no? Superb. Now what this ISP will do, what this Google will do, Google will get back the reply, right? And the reply packet is opposite. Whatever IP we have at the destination, it will be using at source. Source IP address is 888 and the destination IP address is what? 10.1. This thing is clear? It means this package, like Google is receiving this packet and after that Google is get back a reply and the reply, this is the packet, right? Now, google.com forward this packet to ISP again. Now, once this ISP, okay, guys, just to tell me, ISP will receive which packet? ISP will receive source IP will be 8.8.8.8 and the destination IP address will be 10.1. And ISP router, guys, just to tell me whenever router will receive any packets, so the router will check source IP or destination. Perfect. The router will check always destination IP. And what is the destination IP right now? That is 10.1. It means the full IP address is what? 192.168.10.1. This is the full IP address. So this ISP router will check in its routing table. Can you check, guys? We have any 10.0 network in the routing table of ISP? No. Right? So it means this ISP will drop this packet. It means this PC is not able to communicate or not able to use the internet. Why? Because, okay, I'm going to explain you why. Because what happened when this PC forward this packet towards google.com, so this packet is reached to this switch will forward this packet to R1 router forward this packet to ISP is also forwarding this packet to 8.8.8.8. After that 8.8.8.8 get back a reply, and when this packet is reached to the ISP, so when this ISP will receive a packet, so the destination IP address is what? 10.1. It means 192.168.10.1. And guys, I told you one point. this 192.168.10.1, this IP, which type of IP it is? It is a private IP, and I told you on ISP network we do not have a private IP address in the routing table. See, just to read this line, we don't have private IP root inside a ISP routing table. Okay, so this root is not available on ISP routing table. That's why at this point that router will drop the packet, right or wrong. It means this packet is stop where? This packet is reached to the actual destination, but that packet is not get back with a reply, right? It means we can say we have a route to send the packet from source to destination, but we do not have a route to reply. Okay, at the reply time, the ISP will stop this packet. So this is what actual problem. Right now in this topology, NAT is not enabled. NAT is disabled right now. Okay, NAT is disabled. NAT is not enabled. Now, so this is the problem without NAT. After using a NAT, okay, let me do one thing. Okay, let's take an example. Now I enable a NAT on this R1 router. I told you always we will enable this NAT on our edge router. Let's say the NAT is enabled on which router? On this router R1, right? Okay. Now let's say again this PC1, it means 10.1. This 10.1 wants to communicate this 8.8.8.8, right? So again, the source IP address is what? 10.1. Destination IP address is what? 8.8.8.8. Okay. Now what this PC will do? This PC will forward this packet to switch, and switch will forward this packet to R1 router. Okay. Now once this R1 router will receive the packet, so the source IP address is what? 10.1, and the destination IP address is what? 8.8.8.8, and we know the NAT is enabled. So actually what this NAT will do, this NAT will check the source IP. Guys, can you tell me what is the source IP? Perfect. The source IP address is what? 10.1. So this NAT will remove this 10.1 IP. Okay, one more thing. Guys, I need to do some change here in this IP addresses, because now we need to use public IP addresses here also. So now let's take an example. In between ISP and R1 router, I'm using IP 99.99.99.1, and here I'm using 99.99.99.2. So inside the routing table, it will be show me 99.99.99.0 in the routing table, right? Okay. Now let's discuss again the flow. PC, this 10.1 forward this packet to switch will forward this packet to R1 router. It means R1 router will receive with source IP 10.1, destination IP 8.8.8.8. Now, what this R1 router will do? This R1 router will remove this packet. This R1 router will remove the source IP actually. And what is the IP address of this interface? Okay, one more thing. Here we have two things. Inside interface, outside. This interface is what? Inside. This interface is what? Outside. So whenever a router will receive a packet from the user, okay, and NAT is also enabled. So this R1 router will remove the source IP and whatever IP address we have at outside interface. What is the IP right now at outside interface? That is 99.99.99.2. It will be put that IP as a source IP, 99.99.99.99, right? And now this router will forward this packet to ISP, right? And now ISP will forward this packet to 8.8.8.8. Now this 8.8.8.8 PC receive this packet with source IP 99. This google.com will receive a source IP 99.99.99. What? 2, and the destination IP is what? 8.8.8.8. Now this google.com will get back a reply. So the reply packet is what? 8.8.8.8, and the destination IP address is what? 99.99.99. What? 2, right? Okay. Now this this google.com forward this packet to the ISP, right? Now when this ISP, okay guys, you remember earlier when this ISP will receive a IP address, the packet from the Google, so the source IP address is 888 and the destination IP address is 10.1. But now in this time, like after enabling NAT, what happened? This ISP will receive a packet with source IP 8.8.8.8 and the destination IP is what? 99.99.99.2, right? And guys, can you tell me one thing? This 99.99.99.2 is a private IP or public IP? Yes, tell me. This 99.99.99.2 is private IP or public IP? It is a It is actually a public IP. And we know at ISP is always showing me what? Only on public IP, not a private IP. So yes, 99.99.99.2, this ISP will check in its routing table. We have any 99.99.99.0 network? Yes, we have. On which interface? Interface F0 by 0. So this ISP will get back a reply on this port, and then this R1 router will receive this packet. Okay. One more thing. When this when this R1 router will receive the packet, so the packet is like that. In the packet, the source IP address is what? 99.99.99.2, and the destination IP address is what? Sorry. When this R1 router is receiving a reply packet, so the source IP address is 8.8.8.8 and the destination is what? 99.99.99.2. Now, actually, when the packet is going out, when the packet is going from inside to outside, then what this R1 router is doing? R1 router is removing the source IP and put the outside interface IP, right? Now, but when this packet is received by the ISP, so what this router will do? This router will remove the destination IP and put the PC IP address, that is 10.1. And then this router will forward this packet to switch, and switch will forward this packet to R1 router. So it means now the flow is what? This PC will forward this packet to switch, switch will forward this packet to router. Router is what this router is doing? Router is performing what? NAT, network address translation. It means change the source IP and put the outside interface IP, then forward the ISP. ISP will forward to google.com. Google.com will make a reply packet, and reply packet is reached to the ISP. Then ISP will check the routing table. We have a route for public IP. Yes, we have. Then ISP will forward this packet to R1 router. R1 router again check the destination IP and remove the destination IP and put your PC IP and forward to the switch. Switch will forward this IP, this packet to the PC. So guys, this thing is clear. It means after enabling a NAT, this PC is able to access the internet. Without NAT, you know, earlier when we are not performing a NAT, then the packet is stopped at the reply side, right? The packet is stopped where this router is forward the packet here. This packet is reached to the destination, but earlier that packet is stopped at a ISP site, because inside the ISP we don't have a private IPs. That's why. I hope this thing is clear. Why do we use a NAT? Okay, so basically what the NAT is doing, NAT is performing a translation from, yes, from private to public and from public to private. I hope this thing is clear. And when we are using a NAT, so one more thing, when we are using a NAT, so we can use multiple, we can say we can use same private IP at multiple times. Yes, multiple times, but multiple times in different organization. It means, let's take an example. If we have this company and if we have this company, two companies, and we have one ISP here, right? Let's say we have two companies, and in this company I'm using a 10.1 IP, in this company as well I'm using a 10.1 IP. No problem, we can use 101%. It means 192.160 10.1, 192.160 10.1 we can use, because here we are performing what? NAT, and here also we are performing what? NAT. So we can use a same IP in different organization, but we cannot use like that. We cannot use 10.1 here and the same organization we can use again the 10.1. No. Same IP we can use on different organization. Yes, it is possible. And using the NAT, the private IP address is also hide. Okay. See, using the NAT, private IP address is hidden. No one can see your private IP addresses. Okay. So basically, NAT is a translation from private to public and public to private. Okay. And basically it is used to reduce, the wastage of IP address, and we can say the limit of wastage of IP addresses. Or okay, got my point. And if I talk about types of NAT, so we have static NAT, dynamic NAT, and then PAN. Okay, in this video only I'm explaining the very basic, the theoretical, the basic of NAT. Okay, so in the next video we will do the practical, and we are going to more depth. Okay, guys, thank you so much. Bye bye, take care, have a good day.